Good morning, grade 4s. Today we're going to talk about some basic terms that we use for a fancy form of math called geometry. Geometry is basically the study of lines and shapes. So we're going to be talking all about different types of lines, different types of shapes, and all of those things. Now, as an introduction, it is very important for you guys to understand exactly the terminology we will be using. I will be using these words fairly regularly in videos, and you will need to know these because they do help you for other things as well. So I'm going to go through the basic ones. You might recognize some, you might not recognize others, but we're going to basically do all of them. So we're going to start with a point. What is a point? A point looks like this. It's just a single point, a little dot on your paper. It's not anything big, it's something completely tiny. It means that one little tiny thing in space. Pretty self-explanatory, pretty simple. The next one is a line. So a line is completely straight. And the thing about a line is on my paper I can draw it this big, but a line never technically ends. I could keep this line going forever this way or forever this way. And to show that it keeps going on forever, we often put little arrows on the end of the line. That just means that I could continue this line for as far as I wanted to go. It's going to keep going on and on and on. It's just a straight line. It keeps on going. Now, a line segment, on the other hand, is like taking just a piece of this line. And to show that we only want a little tiny bit of the line, we often draw a line segment with little dots at the end of it to show that they are pointed, and that is a specific section it ends. Now, a ray is sort of like the in-between a line and a line segment, because on one side of a ray, it ends, but on the other side, it could keep going on and on and on and on and on and on and on till it wraps around the world even. So that is what a ray looks like. It continues on and on just on one side. Now, angles are different combinations of lines that meet at a point. So, for example, we have right angles. Right angles are the best types of angles because they are really nice looking. A right angle always looks like the corner of a square. It goes straight up and down and across like this. And if we took a protractor, which is a measuring tool we use to measure things, we would know that this angle here is equal to 90 degrees. So we can count how big our angle is, how far our mouth is open. But when it looks like a chair or it looks like a corner of a box there, that's what we call a 90-degree angle. Now, on the other side, we have congruent angles. Congruent angle doesn't mean a specific measurement. It just means that if we had two angles, they would be the exact same size. So for example, this is a good example of congruent angles. So here's one, it's really tiny, and then I'm going to try to replicate that. Oop, and it's not. This isn't the best example of congruent angles because as you can see, they're not exactly the same size. Remember, we're measuring this. But if they are the exact same size, they're what we call congruent. Here's another example. We could have one angle go like this, and another angle go like this too. And we'll notice that these angles, even though they're not chairs, they're not right angles, they are roughly the same size. Now here's the really cool thing about congruent angles. I could do this and make the line parts bigger, but the angle part, this amount of how far the mouth is open, doesn't change. So these angles are still congruent because they're the same amount of open as each other. So that's what a congruent angle looks like. And finally, let's move on to our types of lines. These ones might be the hardest ones to recognize, but I have a special trick that might help you a little bit. So first of all, I like to think of parallel lines as train tracks. So here's my two parallel lines. And the thing about these parallel lines is they will never, ever, ever meet. No matter how long I make this line and how long I make this line, they will always go the same distance apart from each other. They will never actually meet. Sort of like train tracks. Have you ever seen train tracks meet No, it doesn't happen. They keep the same distance because otherwise the wheels of the train would start to collapse and the train would fall apart. So parallel lines do not intersect. They don't cross each other. They stay the same distance apart, just like train tracks. On the other hand, intersecting lines do meet. So here's an example of intersecting lines. These two lines, they are not parallel because they meet here at this point right there. They meet. Here's another example of intersecting lines. Now these ones at first don't look like they're going to intersect, but if I kept drawing the line and kept drawing this line, they would eventually meet at a point. So they are intersecting. They meet at a point. And finally, a perpendicular line also meets at a point, but it meets at a very special point. It looks a little bit like this. And then I draw this little sign here. Think for a minute, where did we see that sign before? It was one of our other ones. If you can't figure it out, this is what we call a right angle. So perpendicular lines meet at a right angle. So they create this sort of square pattern here. So they meet at a right angle. Now you will want to work on knowing which terms are which. So if you are a little bit confused, I encourage you to watch this video over again and just see what all those different types of things look like and what they are and what they do. So there you go, those are the different types of lines. Now before I leave you, I did notice that some of you had a bit of trouble with the division question, the division algebra question on your homework yesterday. So I'm just going to address that. If you don't want to listen, you can just skip out. I'm just going to try a question right here at the top of my page. Don't have a lot of room, but that's okay. I can work with that. So your question looks something like this. This isn't the same question, but it's the same idea. So I have x plus 1 equals 15 over 3. Uh-oh, that looks like a fraction. Oh no, how can I do fractions and algebra? I didn't know how to do that. Well, take it easy for a minute, because this fraction simply means to divide. This says 15 divided by 3. I can even rewrite that. I can say x plus 1 equals 15 divided by 3. And now that it looks like that, I'm just going to follow my regular steps. I might run over my line, but that's okay because I don't have a lot of room. So the first step I'm going to do is I'm going to solve that. 15 divided by 3 gives me 5. So I have x plus 1 equals 5. And then I don't want that plus 1 over there because I want my x all by itself. So I got to balance my scale. I got to do the opposite of plus 1. So x plus 1 minus 1. And because I put a minus 1 here, I'm going to put a minus 1 here, 5 minus 1. So now these two cancel each other out. I'm left with x. And here, 5 minus 1 gives me 4. So x equals 4. Then I just check that really quick. So 4 plus 1 equals 15. And I don't even have to write it like that. I'm going to write it using the divided by sign like that. 15 divided by 3, that means 5 equals 15 divided by 3 gives me 5. 5 equals 5. My answer is correct. So if you got a little bit confused, that's how you do it. Okay, everyone, goodbye.